I'm really excited to bring this discussion with Raymond Appy to you today. He runs a biochar company that makes biochar from biosolids. As you may or may not know, biosolids is a huge problem. We don't know where to put it anymore, especially in places like New York State, where they're closing landfills, and obviously incineration is not a good idea, and land application is challenging as well. Biochar is an amazing substance that is created through pyrolysis, and that process actually cracks PFAS, which means it gets rid of PFAS and other toxic compounds and chemicals. So I spoke with Raymond today about his process, what he's doing to help with the biosolids problem, especially here in New York, and also the problems that he had in his first project that actually was closed and stopped by the local community based partially on misinformation. And so I hope that this discussion clarifies what biochar is and what his project is for many. He's moved on to greener pastures in other communities in other states. But in the meanwhile, this is our discussion. I hope you enjoy it. And coming soon is a longer film called The Biochar Effect that actually goes into many more other implementations of pyrolysis and biochar with different feedstocks, different materials, and it's just fascinating. So I hope you enjoy it. And yes, here it is, our discussion with Raymond Appy. I would love to talk to you about your experience here in upstate New York. And I actually spoke often about what was happening up there and advocating on your behalf, even though I didn't know you. I was like, biochar is actually the future, and I'm not sure why we're going hard against this project. But actually, let's just get into it and hear what you're doing now. But let's start from the very beginning. Could you just tell us a little bit about yourself and how you came to biochar in the first place?
Sure, and thanks for having me and doing this interview, Leila. I appreciate it. A little background on myself. I am late 50s. I developed a technology business for over 20 years and sold it in 2017 and worked for the buyer for a couple of years. And then I decided in 2019 to quote unquote get back to my roots. I considered retirement in my early 50s and I thought that would be dumb. I'll probably get in trouble. So, but my background is in educationally is environmental science and policy. I have an undergraduate degree and a graduate degree in those areas of study, and I worked in the field for about 5 years during and after graduate school in a few different capacities. And one of the things that I was always really interested in was the waste management space. And what interested me is that I understood the basics of waste management engineering. I studied and worked in and around landfill technology and hazardous waste management and hazardous waste landfill technology and wastewater treatment systems and all these things. And I looked at it all seemed, even back in the 90s when I was studying it, it all seemed kind of antiquated to me. And I was curious, why do we generate more and more garbage and we talk about recycling. I'm not sure how effective that is, especially with plastics, but we take all this stuff and put it in holes in the ground for the most part, as opposed to like recovering more meaningfully recovering resources. And so that was of interest to me. So I decided you got to pick something to focus on, right? And not try to boil the ocean. So I thought that one of the things that's probably the least good for landfill technology is putting organic waste into the landfills. It causes all kinds of problems. It's not really, it doesn't help landfill design. It contributes to leachate problems. And especially if you're dealing with organics that have contaminants in them, then maybe there should be handled differently, or there should be a better way. And I had become aware of biochar and the concepts of carbonization, and of course was curious about how impactful could this be relative to long term to things like climate resilience and carbon sequestration. And I started to put all that together and really started to lean in on biochar, methods for making it, what to do with it, the history of it dating back 2,500 years to the Amazon basin and all that stuff. And I got just more and more interested. And so by late 2019, I decided to form a business that was going to get into biochar manufacturing. And so I actually founded Northeastern Biochar in December of 2019. And even before that, and then of course, in the year 2020, I set about developing technology, finding partners, figuring out what I was really going to do with this interest. And in 2021, I had partners. I had multiple manufacturing partner options. Was still kind of evaluating. Hadn't made really a close manufacturing partner decision yet. And I did a capital raise in 2021 and brought in some money to really get serious about it. But during that time, the initial year or so, I landed on pyrolysis as the way to go. And the reason for that is I looked at the options, and really it's pyrolysis or gasification. What I liked about pyrolysis more is that if you're going to take an organic waste feedstock and try to maintain the solids as much as possible, put as little as possible into the air, so to speak, and put as much as possible back into the ground, you get better control with pyrolysis. Gasification is very effective. It operates typically at a higher temperature. You end up with more ash, probably more air emissions, more nitrogen-based air emissions, maybe more emissions controls considerations and things like that. And it seemed to me to be more about capturing all of the energy, or as much possible, from organic feedstock materials, and using, doing something useful with that energy, with that captured gas, the synthesis gas. And I thought, well, that's interesting, but what could I do with that? What could I do with the synthesis gas that's generated on site? Actually use it back in the process, but maintain as much of the solids as possible, release as little ash and things into the air, and try to get to like almost a zero waste type of scenario. And I thought that pyrolysis was more suited to that. We can get a lot done at a bit lower temperatures. There's much better control of the temperature throughout the process. I won't get into all the technical details of how and why that is, but that's how it is. And it operates in a zero oxygen environment. It's heating from basically an external heat source. You're heating material inside a shell, and you're not exposing that material to air. And so that alone produces a better carbonized product and more retention of solids. And so they continued on that path and finally found a really strong partner, manufacturing partner to work with. Spent plenty of time and money on a specific facility design that matched my interests in what I was trying to do. And what I was trying to do, and the reason why, was I had decided I was going to focus on biosolids as a primary feedstock source. Biosolids, as I'm sure you know, maybe not everyone hearing this or seeing this knows, is the treated sludge that comes from wastewater treatment plants. And I say it's treated because it is, but it's not necessarily clean. But it's the settled solids that come out of the wastewater, which are then allowed to anaerobically or aerobically digest. And basically, in a digestion system, all the bacteria consumes the organic matter that's there, explodes in population, then the bacteria dies, and what you're left with is a bit of a nasty sludge. And volatile organic compounds and metals and things like that typically don't change much in that process. So you have this basically sludge that's loaded with carbon, macro and micronutrients, and some contaminants. And we consider the contaminants really, for the most part, trace amounts. They're not in high volume. It's not considered a hazardous waste, but there are things in there that are considered toxic. And specifically now, kind of the poster child for contaminants of concern within biosolids and many other things are PFAS compounds, per and polyfluoroalkyl compounds, which are often dubbed as forever chemicals because they're very resilient and they just don't break down very easily or in nature. They don't degrade naturally. And the reason is because they are formed by the strongest bond in chemistry, which is the carbon and fluoride bond. So anyway, I recognize that this is a great opportunity to do something meaningful, because I started really reading about and understanding the problems that biosolids disposition, or the disposal of biosolid waste, has been causing. We put a lot of it into landfills. It's not so good for landfills. It causes the most obvious thing is it causes really nasty odor problems. It's often used as a daily cover and kind of put on top. It's pretty good for holding down paper and plastics and things from blowing away, and it's not a bad way to cap other materials. But then you're putting all that rotting organic right at the top, and it's creating a lot of methane. That's a arguably 23 or 25 times greater greenhouse gas versus just CO2, and it releases a lot of odor. So I mean, a lot of the odor problems that are bothersome to neighborhoods that are in the vicinity of landfills has to do with the disposal of biosolids. Unfortunately, that's one of the most odor causing problems And that, generates a lot of resistance to the expansion of landfills, and certainly for the siting of new landfills. And if you look at how urban, suburban, and rural areas have developed over the last 80 years. I mean, typically we put landfills kind of far outside of town where they wouldn't bother anybody, and then town got bigger, and before you know it, the town's wrapped around the landfill. And you've got suburban developments with $1 million homes that are within a mile, and people don't like the way it smells, and they certainly don't like it when the stuff blows out of there and ends up all over the place. So I saw that as something that we could focus on. And the other side of it is that biosolids, the material that comes from publicly owned wastewater utilities, is a regulated waste, and it can only be disposed of in three different ways in all of the states of the U.S. And those three methods are landfilling, or direct land application, or incineration. So we talked a little bit about landfilling. It's got its problems. It's getting more and more expensive. I could tell you why it's getting a lot more expensive in New York. It mainly has to do with the closure of two of the largest biosolids receiving landfills in the state. The largest one was the Seneca Meadows landfill, which finally closed completely on December 31st of 2025. And that was among the top three largest receivers of biosolids in the state for many years. It's now fully closed. And then not far from there in Western New York is the Ontario County landfill, which is slated, that's municipally owned. Seneca Meadows is privately owned and operated. Ontario County is municipally owned. It's been designated for closure by 2028. It's currently operated by a public waste management company, and that is also in the top three largest receivers of biosolids in the state of New York. So that one will be offline within 2 years. So that alone is placing tremendous constraint on the methods for disposing of this material. And in addition to that, if you look at the state's permitting cadence, I'll call it, relative to landfills, is typically when a landfill gets a permit extension or an updated permit for operation, typically what we're seeing is that the state DEC is reducing the amount of biosolids that facility can receive on a daily basis as a percent of total volume. And not all landfills are permitted to receive biosolids at all. In fact, most are not. There are not that many that really can take the material. And the ones that can take the material are, I call it, every time they get a renewed permit, they're getting a haircut on biosolids. So that's a lot of constraint in the industry. What that does is it just pushes the cost to taxpayers to try to take the material further away. And in the state of New York, we export more biosolids than any other state in the union. New York State sends more biosolids outside of its borders than any other state. And that's very expensive because dewatered biosolids, and I say dewatered, it certainly doesn't mean dry. It means most of the water's been squeezed out of it, but they're still ranging from 75 to 80% water content. So it's very heavy. To load trucks with this stuff and take it far away it's not very efficient. And it's not very environmentally friendly. And in fact, the city of New York sends a large volume of its biosolids by train currently to Alabama. And that's tremendously expensive. And I think the folks from Alabama are pretty unhappy about it. And I don't see that that's going to be able to continue for too much longer. But anyway, that's all done on a contracted basis. And you can't just take this stuff anywhere and get rid of it. It takes time to set up transportation and facilities that can receive it and contracts to do that. It just doesn't happen overnight. It's not like flipping a switch. And so the reason I'm saying all this is because that's the financial driver. It's very expensive to get rid of this stuff now, and it's getting more and more expensive by the minute here in New York State because of these things. And I'm about to tell you about one more thing that's really driving the market, and this is the big one. In the state of New York, a bill was introduced into the state assembly, and I think 2022 or maybe 2023 by Assembly member Anna Kellis, who's from the Ithaca, New York area. And the bill was a proposal to put a moratorium on land application of biosolids. We haven't talked about land application yet, but a lot of biosolids in the state of New York are taken to composting facilities or lime stabilization facilities where the material is further processed to make it safer for handling and for literally spreading on land to reduce the pathogen count and disease vectors and things like that. Composting does raise the heat a little bit. It will break down quite a bit of volatile organic compounds, but certainly not all, and certainly not PFAS. and then it's spread on land. And I don't know exactly what the number is now. I think a 2015 report indicated that somewhere north of 20% of the state's biosolids were land applied. I've heard that the numbers now are closer to 40%. Anyway, a lot of material currently goes to land application where it's used as a, call it a fertilizer, a soil amendment. I can understand the concept 30, 40 years ago before we really thought about the contaminants, and certainly the more persistent contaminants in biosolids. I understand why we thought, hey, it's kind of like cow manure. We'll just take it back, put it on farm fields, and it's going to put the nutrients back in the soil and organic matter and all these things. And okay, well, that makes sense. The EPA supported it. It really started at the federal level with EPA support, and all the states did it. And now 2 states don't do it. The state of Maine and the state of Michigan, I think, have banned it already. And the state of New York is considering this. So back to Anna Kellis. She proposed this bill in the assembly in 2023, and she didn't get enough support. She tried, and it never made it to the assembly floor. It didn't even get voted on. It got pushed out. State Senator Harcum from Hudson Valley picked this up and brought it to the New York State Senate. The bill at the Senate level was voted on in 2025 and passed. He got enough support. The bill did pass the Senate in roughly the same format it was when Anna Kellis first proposed it years ago. And the bill is fairly shortly written. It's pretty succinct, and it basically says, it's an immediate stop, a hard stop on land application of biosolids for 5 years, a moratorium on spreading it, which would give the state time, and money would be dedicated to study the effects of it, study the alternatives, learn more about PFAS and its long-term impact on health and environment and all these things. I mean, that's hard on the taxpayers, and it's hard on the wastewater utilities to be like, oh my God, I got to flip a switch and do something else tomorrow. I mean, I've spoken to some wastewater utilities that think that their disposal costs are going to double overnight. If that happens. Now, it remains to be seen. Will it actually be tempered a little bit? Will there be some relief valves given to kind of ease into that, or will it be a hard stop? Remains to be seen. But it passed the Senate. It made it to the New York State Assembly in 2025. It made it to the floor of the Assembly, and then they went on break for the second half of 2025. They're back in session now since January. And a rumor on the street has it that bill it has made it to the floor. It has substantial bipartisan support. I think at least a dozen assembly members, if not more by now. And it's supposed to be voted on by the end of next month. And so the industry is quite confident it's going to pass. We all kind of see this coming. And so I see what we're doing as a relief valve for this problem. Okay, well, we can take these materials. We can thermally process the material, we can carbonize it, we can upcycle it, make something very useful out of it, decontaminate it, and get rid of this problem and have no solid waste left. So that's really kind of what's been driving me. That's the financial driver. That's the reason, or those are the reasons why I've really focused on biosolids. And then I'll talk briefly about incineration. The state of Connecticut still does quite a lot of it. Some places in New York incinerate biosolids. Albany County does. They have 2 biosolids incinerators right in the city of Albany that still operate. And they're trying to re-up their permit for those by enhancing some emission controls. But basically, I am aware that the incinerators in Albany don't operate at a high enough temperature to crack PFAS. So, they're releasing PFAS from the solids, and theoretically, most, if not all of it, is going up the stack and right into the air. And those stacks are not that high, right into the city of Albany area. So that's a little scary. I'm curious to see how that shakes out. But so anyway, incineration is still happening. Maybe 15% of the material is incinerated here in the state of New York. A lot of it is in Connecticut and in other places. But, incineration technology its legs have gotten pretty short. I don't think it's going to be around too much longer, but it is still there. And that's where the rest of it goes. So
yeah, I mean, anyway, it's interesting.
So that's kind of the background on how I got into it. And what I've done to develop the business the first few years, and why we focused on biosolids first as the primary feedstock. So I'll pause and see if you.
No. I'm on your page in the sense that I understand that we filmed multiple places that have taken biosolids and pyrolyzed them. So in Germany and California, it's well known to work, and it is actually waste to value, and there's no reason why biosolids shouldn't be pyrolyzed. So I hope that this conversation, helps people understand, and the upcoming film, which will show the images of it working, as you said, if you pyrolyze waste, it cracks all of these volatiles and gets rid of a lot of these toxins, and then you can safely apply it to land. We did a movie a decade ago, at least, around rights, around community rights, and a lot of communities got into community rights because of biosolids, because kids literally would go across fields of biosolids and literally contract horrific infections and die. So, it's not that safe all the time. I'm sure some of it is, some of it isn't. But anyway, why do that when you can do biochar, which even has all these other sort of benefits, additional benefits to the soil, because it creates basically, people say this a lot, it's like a coral reef for the soil. So it allows for all sorts of microbial life to live and to make the soil more resilient to droughts and floods and all that. So it's a win-win-win-win. So let me just get into a little bit about the difficulty you had. I guess that's an understatement. So explain to the audience, so you tried to do this, you tried to put a biochar pyrolysis, plant. What was it, in Glens Falls, right? Was it Glens Falls?
Outside of Glens Falls. It was in the town of Monroe, New York, which isn't the Glens Falls area, but it was planned to be in Monroe, which is the north end of Saratoga County.
And everyone basically flipped out and shut it down. So what happened? So help us understand.
Basically this kind of picks up where I left off. So we talked about why biosolids, why pyrolysis, and I will say this though, as it relates to land application, I it seems like it's going to come to an end, but I'm not quick to jump on the bandwagon of disparaging the fact that it's happened in the past. I think in the areas of waste management, of environmental awareness, of continuously trying to do things better as society, as humanity, we're always trying to up the game. And it's new technology, new processes, better ways to do things. I mean, we used to not line landfills a long time ago, and then we started doing landfill liners. We have better landfill liners, and all these things. And, the land application probably, I can see how it made a lot of sense.
It was a good idea at one point. Yeah, of course. I'm not bashing it. It's just that people have had issues. It's not sort of as clear of a win as biochar is, as far as I'm concerned.
And also, as it relates to PFAS impacts on human health and environment, I think we're still a bit in our infancy of really understanding that. I mean, people are quick to, I understand it, quick to be like, oh my gosh, this is terrible, everyone's going to get cancer and die. And well, maybe that's not really true. I mean, and also not all PFAS is created equal. There's a wide range now. There's I don't know, maybe 50,000 variants or somewhere in that range. But, the ones that are of most concern, the most resilient ones, are considered the long chain PFAS. And they are literally, if you look at the chemical compounds of various PFAS compounds, some are actually quite short, and those tend to actually break down at lower heat values more easily. The longer chain ones are more resilient. So that kind of the poster child for the real bad ones that have really been, for the most part, removed from manufacturing and aren't used much at all anymore are PFOS and PFOA. And in fact, the EPA, and I think last year, maybe 2024, deemed those two as hazardous substances. So, these things are working their way out of the system. They are. But, there's a lot of it's already out there in the land, in soil, and in our bodies, and in our bloodstreams, and in fish and everything else. And, we have to deal with this. But so anyway, that's the kind of my thoughts on land application. But what I tried to do first in business, and maybe, I certainly, what is it that Yoda said from, you ever watched the Star Wars?
Oh, of course. Yes.
Yoda said, failure, the best teacher is. Well, you learn from your failures, and I learned a lot. So what we did in our first effort to commercialize our business, after developing our technology and lots of research and lab analysis and data gathering and fundraising and all these things, we tried to get permitted quite a large facility in Monroe, New York. It would have been large enough if we proposed it to be built in 3 phases, not all at once. Each phase would process about 75,000 tons of wet biosolids per year and would produce about 7,500 tons of biochar per year. And so phase 1 was one process line that did that. Phase 2 would be a second one. Phase 3 would be a third. So when fully built, after about a 5-year ramp up period, we would theoretically be processing about 225,000 tons of wet biosolids per year. There was nothing to say that we would have ever got that far. I mean, we would have had to build phase one and prove it, and do stack tests and prove the reliability of the equipment, the reliability of the emissions controls, do continuous air monitoring. I mean, I had a laundry list of things that we had formally agreed to do with the community as part of our site plan approval, which, by the way, we did get an approval. We were approved. We had a site plan approved by Monroe. We had a state environmental quality review negative declaration, which meant that minimal environmental impact was the decision. That decision withstood a court challenge, an Article 78 court challenge. The Supreme Court of New York State sided with us that the state environmental quality review had been done appropriately, and in a 50-page decision supported us. And then it was appealed, and we lost on appeal almost 2 years later. But by that point in time, it didn't matter anymore because the horse was out of the barn, and everybody was kind of riled up against the project. And really, it has a lot to do with just lack of understanding of emissions controls, of how PFAS can be destroyed, and also a lack of a wide data set, at least at the time, that demonstrates PFAS destruction with thermal processes. Now we really have that. I mean, the bad news is we couldn't get it done then. The good news is there's so much more data out there now. And as a matter of fact, the company that will manufactures thermal oxidizers, which will actually be the place where PFAS goes to die. That's effectively the first step in the air emissions control. They now have demonstrated stack test analyses that prove that what they said will happen. So I didn't have quite that much in 2021 when we first filed our DEC permit applications for Monroe. We didn't have that. We had theoretical, we had data from other countries, we had research papers. Now we've got proof at scale. So it's a different animal.
Was it the main issue? Was it that the community didn't want the potential for PFAS to come out the stacks, or was it they didn't want the trucks to drive in the biosolids?
I'd say it really started with there's a few people, or the people who live immediately around the Monroe Industrial Park, who ironically most of them purchased their property around that park after the park was created. So they got the property for almost nothing, right next to an industrial park, built houses there, and then decided we're going to fight anything that comes in here that might be remotely industrial, because we don't want truck traffic, and we don't want to hear anything. We don't want to see anything. We don't want to smell anything. It's like, well, okay, well, you got your property for nothing, and now you're stopping it. So whatever, that is what it is. But that's really where it started. It started with people who lived right around the park, concerned about truck traffic and noise and potentially odors. Mm-hmm. And we tried to demonstrate that, noise is minimal. Noise would be less than the existing formaldehyde manufacturing facility that's already in that park. And that trucks would be minimal. The park was conceived to be able to handle over 1,200 trucks per hour at peak periods of the day. And our facility, and they never got anywhere near that. The formaldehyde company is the only one in there, and they've got maybe 5 to 10 trucks a day. The rest of the park never got built out. That never came to fruition. I actually don't think that traffic study was correct. I don't think that the local roads or even the park roads could handle that kind of truck volume. But that's what was written in the environmental impact statement and approved by the state all those years ago. But we would have only at most ever, with all 3 phases operating at full capacity, we would have never had more than 50 trucks per day coming and going from the facility.
Right.
So relatively speaking, it was a drop in the bucket of what that park was designed for. Mm-hmm. Although I think 1,200 trucks per hour was excessive. I think
seems like a lot.
We would have had to make the roads bigger. Yeah, that's a lot.
No, that's a lot. And for small.
But I don't think it would ever get built out that far.
And did people did the environmentalists attack the idea of pyrolysis? I know that when I first came to New York State, that a lot of because of the climate bill in New York State, they banned burning, and they don't understand that pyrolysis is burning. Was that part of it too at the time? Or
absolutely,
has that improved?
Absolutely, yeah. So it started with the concerns about truck traffic, noise, and odors, and so we at least with the planning board, we dispelled the concern about that, and the planning board and the town board were fine with it. But But then the folks really started to get organized, and it was taking the state of the DEC quite a long time to process the permit applications. And that lapse of time allowed the resistance to grow. So the next step was that the folks that live around the park co-opted the help of an environmental group out of Glens Falls called the Clean Air Action Network, and they brought in people who were anti-pyrolysis. So to your point, they're like, oh, this is just another form of incineration. Well, no, it's not. Incineration burns the solids. We don't burn the solids. We just heat them. It does create a synthesis gas that we have to do something with, and we combust the gas. And then we treat the air emissions from the gas, and the treatment for the air emissions is quite common. It's used in industry all over the world all the time, and it's very effective. And then they brought in this expert and that expert that said, oh, PFAS can't be destroyed. They brought in some woman who worked for DuPont or something 100 years ago, and she's one of these people that was the reason why we have PFAS compounds. And then she got paid money to come out and say you can't break PFAS compounds, which is completely false.
It's not true. You can.
It's not true. We've proven that we can. And then just on that for a second, it gets broken down in two different phases of our process. First, the pyrolysis kiln itself will destroy all the short chain PFAS because it operates at 1100 degrees. And a lot of that stuff breaks down at 1100 degrees and it ends up in the synthesis gas as hydrogen fluoride and other minerals. It's not a problem. The longer chain PFAS survives pyrolysis, and then immediately that gas goes from the pyrolysis chamber directly into an advanced thermal oxidizer where it's fired at 2,600 degrees. No PFAS survives 2,600 degrees. It's completely broken down at that point, and it's a multi-stage oxidizer. So there's a firing zone at 2,300 degrees. Then there's a condensing zone where we cool it to about 1,600 degrees, still extremely hot. And in that, and one of the interesting things about our technology is we take the water, the scrubber water, from one of the scrubbers, and we use it from the first wet scrubber, and we use it to cool and condense in the thermal oxidizer. And by introducing the water stream at that point, if any PFAS made it through and actually got caught in the scrubber water, it's getting destroyed. And it's going back into the thermal oxidizer. So poof, it's gone. And then we fire it again on the third stage at 1,800 degrees. And then the hot gas from there is used to dry the inbound material. It goes through the dryer, and then from the dryer it goes through all the air emissions controls. But anyway, so the Clean Air Action Network got involved.
Excuse me. I talked to the California Bioforce Tech, and they even measured their emission. It's nowhere. It's cracked. It's gone. It's metabolized.
It's gone.
It's gone.
And it does produce hydrogen fluoride, which that's a bit of a dangerous byproduct. That's not something you want to or could release into the environment. But we employ an acid scrubber. We use a hydrated lime, which actually because HF, hydrogen fluoride, is an acid gas. So we use hydrated lime to take the acid gas out. So it's gone. It's gone from the emissions. Even the byproducts are gone.
Yeah. Exactly.
And so anyway, so at the end of our emissions controls for Monroe, we had proposed 2 dual bio scrubbers as a finishing step, complete odor polishing. The thermal oxidizer gets rid of all the nitrogen oxides. So it's a very clean emissions. We proposed that we put the stack 115 feet up in the air, which was higher than the DEC even needed for dispersion. And we did air modeling studies that showed that there would be no harmful effect beyond the property border, much less outside of the town. But one of the things that really changed, that we kind of got the rug pulled out from under us in that permitting process, was in 2022 to 23, New York State implemented through the CLCPA, the Clean Air Act, basically the Climate Leadership Community Protection Act, implemented what they call disadvantaged community and environmental justice zones. And 2 of the communities adjacent to Monroe, Fort Edward and South Glens Falls, were rolled up into that assessment and designated as disadvantaged communities and or environmental justice zones. Those are areas that have maybe historically had an
disproportionate amount. Exposure. They're called sacrifice zones. Disproportionate amount of dumping and stuff.
And maybe that's coupled with lower income, and maybe that's also in some places is relative to environmental justice is coupled with racial divide and all these things. So those areas got designated in the middle of our permitting process And that raised the level of scrutiny, and it raised the amount of work that we had to do just to get through the permitting process tremendously. And so one of my initial questions when I first heard this from the DEC Region 5 was like, well, we're in Monroe. We're not in those communities. And I'm like, well, yeah, you're close to it. And I'm like, well, what does that mean? How close can you be?
Mm-hmm.
Well, we don't know yet. I'm like, well, you got to tell me, is it 200 feet? Is it 200 yards? Is it 2 miles? Then they ended up
right. There needs to be a
I think they kind of arbitrarily picked a number. Okay, anything within 2 miles or whatever it was, 2 miles of a disadvantaged community is subject to the additional scrutiny and all this stuff. So we kind of got the rug pulled out from under us in the middle. And I tried to argue that, like, well, aren't we kind of grandfathered in? We've been in the middle of this permitting process for almost 2 years now, and you're telling me now this. So okay. But what happened was the opposition used that very aggressively for getting to try to turn and get political pressure to support the opposition versus supporting the economic development.
Yeah.
And also a big deal in the middle of all that was the 2023 election cycle, where the town supervisor for Monroe was voted out of office, and one of the board members was voted out of office, and they were replaced by people who supported the opposition. And so now the politics in the town changed. They immediately implemented a ban on industrial development, a moratorium on any plans for industrial for the industrial park or any other industrial zones in the town, and really made it extremely hard for anything to move forward. And I'll say this too: there's a developer who owns properties in Monroe. I'll leave the name out of it, but he owns low-income housing properties in Monroe, and he had options on property for additional developments of low-income properties in Monroe, which are fine. I have no issue with that. But what was really going on in the background is that the Monroe Town Board and the supervisor were starting to push back on the additional planned urban development plans from this company, because the tax base was getting upside down. They were getting too many bedrooms and not enough tax. They wanted more focus on industrial and commercial development, manufacturing, things like that, to increase the tax base versus low-income housing, which is a drain on the tax base. And they didn't have the infrastructure to support 1,000 more bedrooms in the town. Quite frankly, this is simple math. I mean, it's municipal economics 101, and they understood that. And during the middle of all this, one of the smaller paper companies, which operated in South Glens Falls, went out of business after many, many decades and laid off whatever it was, 80 or 90 employees. I don't know if my numbers are correct, but I believe that business provided $16 million into the Monroe tax base, and that disappeared. That disappeared overnight. And so what was really going on in the background is the opposition to my project co-opted the support of the developer, who spent a lot of money on ad campaigns and slander campaigns against the town supervisor and the board at that time. Had a lot to do with swaying public opinion, and also lobbied with other local politicians to get them to write letters to the state, to the governor's office, to the DEC, opposing the project. So at the end of the day, we ended up having like 5 or 6 local regional politicians writing letters opposing the permits and lobbying with the governor's office to make this go away, and that's what happened. They made it go away.
Yeah.
So,
well, it's very interesting coming from my perspective. First of all, there's an industrial park. Forget about what you're doing, but it's an industrial park meant to, allow 1,100 trucks a day or whatever, 1,200. I mean, an hour. And it seems like, regardless of the activity, the community didn't want industry there anymore, even though industry is obviously paying for the taxes and all of those things. We had this similar thing in LA, Los Angeles, where, there was a lot of oil, drilling for oil all over LA, actually, and whole neighborhoods would grow up around the drilling and then start protesting the drilling because they don't want it there, even though it was an oil field before the houses, right? So what I find interesting about most people is they don't understand how things are made, what it takes to run a town, what it takes to create energy and materials, and what to do with all the sewage sludge.
Goes.
Where the trash goes.
Where does it go when you flush the toilet?
Where does this all go? Correct. And most people don't understand the structure within which we live. And so some of these, well-meaning people who want a good life. Of course, we don't want to have destruction and pollution. And if someone says you are polluting, everyone's like, oh, we don't want them to pollute, but they won't look below the hood and figure out exactly what you're doing, right? That you're actually cracking
Right.
PFAS. It's actually going away.
Yeah.
It's actually solving a great problem. It's actually providing jobs. It's interesting that and it's getting worse with short attention spans and social media and all that stuff, that it's very hard to educate people around some of these very complicated things. And biochar, this is why we made the movie too, is like biochar is so complex just in its detail and all of the additionality and all the things it can do. So I'm really sorry that this happened to you. And that people didn't take the time to learn about what it is that you were doing. Because it probably would have been great for that town. It would have provided jobs, probably, right? It would have
25
solved a
jobs,
lot of
tremendous, 25 full-time jobs, tremendous boost to the tax base, a lot of other related business. We would have sourced all of our services locally as much as possible. So yeah, I mean, the interesting thing at the end of the day, even if we had built out all 3 phases, it would still be classified as a light industrial project. I mean, it's nothing like, you think about like an Amazon distribution center, you could see those from the moon, I mean,
it's true.
Nothing.
Yeah.
It was like a nothing compared to so much stuff that goes on. And I heard from a fairly senior person at New York State DEC that was like kind of blown away that they had received almost 500 letters about this project, of which roughly 450 were in opposition. And they recognized that it was such a small project. Now, this was an off the books conversation. And the person said to me, we didn't get that many letters when Global Foundries built its first fab in Malta, New York, which you can see from the moon, and is a massive project that deals with massive amounts of seriously toxic chemicals to manufacture chips. And they do a good job. They don't have any problems. I mean, yeah, it was
it's education. Yeah. Well, it sounds to me
at
that
the end of the day,
yeah.
Leila, I think there's a critical thing here. At the end of the day, if you're going to upcycle waste, and even if it's such a clean thing, and what people are still going to see it as, and what it has been seen as, is a waste management facility. It's like, maybe in people's minds, this is akin to, or they're going to put a landfill in, or they're going to put an incinerator. It's nothing like that. It's a carbon fertilizer manufacturing facility that's relatively small. It just happens to use biosolids as a primary feedstock source,
right.
and
it's a feedstock question.
Head around that this can be managed and that odors can be contained or eliminated, and it can all be done so cleanly. They just couldn't believe it's possible. So at the end of the day, it was a not in my backyard movement. I mean, it was so explicit, so obvious. We had to do, because of the environmental justice and disadvantaged community stuff, we had to do 3 community engagement activities. One was a virtual meeting, and then 2 were in person, which we did in Hudson Falls. And one of the folks who is a leader of the Hands Off the Hudson movement out of Fort Edward, a person who I actually respect very, very much. Her family's gone through hell. The cancer rates are higher there because of all the PCB cleanup and the mess that General Electric left there. Sure. They've been through hell, and I get it, and I have great respect. And at the end of the second session, she was sitting in and kind of sitting back and watching. She asked a few questions, but at the end she said, "Ray, I think I'm finally starting to understand what you're doing here. And maybe it's a good thing, but we just don't want it here. Take it somewhere else." That was recorded. That's on video. It was in the news. It's like, you can't be more explicitly not in my backyard than that.
Yeah.
One of the leaders of the movement was like, well, I kind of understand it now, and maybe it's a good thing. We just don't want it here.
That's also complex, right? And everyone has a right to the way they want their community to be. Sure. And
but at the end of the day, Leila,
it's complicated.
It just wasn't meant to be there. It wasn't meant to be.
So now what are you doing? So there's some good news now, right? You're moving on.
Very good news. So a couple things. When I saw the writing on the wall that, okay, we had spent an awful lot of time and money, investors' capital, trying to develop a quite large project, which ultimately would have been a very large project with 3 phases built. Large from the perspective of something like this, which isn't done at all yet in New York State. Not large in the perspective of other industries, but big for me. I thought it was pretty good. With all 3 phases built, it would have processed the equivalent of 15% of the state's biosolids in one spot in a facility that uses less than 4 acres and is under 50,000 square feet. It's incredibly efficient and low end. I mean, we have a negative greenhouse gas footprint of 137% greenhouse gas negative. verified third party by eco engineers life cycle analysis. Anyway, that's another topic. But what we're doing now, so when I saw the writing on the wall, I'm like, oh, this is going downhill. So we're going to have to either give up or buckle down and do this, look at this differently. I decided to learn from my mistakes. When we first started the business, I didn't think that it would be possible to sell our technology directly to wastewater utilities, which is kind of a nice way to go. We just downsize it, attach it directly to the medium and large scale wastewater utilities and process the material right there where they already have an air permit. They've already got, the waste management permit, waste management facilities, it's kind of already there. As long as they have land space and can fit a little extra equipment in a small building we'll put it right there. I didn't think that was possible because wastewater utilities operate 24/7 by 365. There's an absolute necessity. The water never stops coming in, and they're very risk averse. And that's the reason why, because the water never stops coming in. They need stuff to just be very reliable, and they're pretty leery about adopting new technology or certainly creating a dependence on it without seeing it, operating somewhere else. So we had originally thought that we need to do a merchant facility. It needs to be a centralized processing facility. We'll bring in biosolids from a region. We'll make it big enough so that it's economically viable. Anyway, I started to downsize our designs. We designed equipment that takes a much smaller footprint and operates at a smaller capacity. And we started to market that directly to wastewater utilities around the country. And we have quite a few projects in the works right now to install equipment directly to wastewater utilities on a much smaller scale. In some cases, the utility, they may be in some cases, they already have a biosolids dryer. So we're just adding pyrolysis and thermal oxidation and air treatment. In other cases, they don't even dewater it. I've got a couple out in Colorado that they're pumping out 2% solids material into trucks and taking it out and land applying it on the ground.
Oh, wow.
2% solids, it's like, okay, they don't even have a dewater.
So it's basically a water tanker. It's a water tanker.
Yeah, they are. They're literally hauling it out in tanker trucks and spraying it on fields. It's terrible. But anyway, so they need a lot of help. But so that's one thing. And the other thing is that I was approached by, I'm not going to name it yet because we haven't gone public yet, but it will be very soon, probably by the end of March. And that I was invited by a county industrial development agency at another county in New York who was paying attention to the news and said, hey, I see what's going on there in Monroe. We'd love to have you here. We're starving for economic development. We have bond grants and money available. We need jobs. We have plenty of manufacturing land already zoned appropriately available. And so we engaged with that opportunity immediately, and we've been working on it for over a year now. It's going very, very well. It's in a different region of the DEC, and a lot of it has changed since then. The things that I mentioned earlier, the landfill closures, the pending moratorium on land application, everybody knows that these things are happening and that the whole industry is evolving. The waste management industry, all the companies that haul biosolids today, they know that everything's going to change. There's one company that operates a lime stabilization facility in northern New York that receives about 90,000 tons of that material per year, and lime stabilizes land applied it. That's about 20% of their business, and they are quite concerned it's going to go offline overnight. So there's a lot of attention. Everyone, and also there's a lot more research. There's a lot more data out there. There are more organizations that have been doing these kinds of things now at scale. There's Aries Clean Energy in Linden, New Jersey, which kind of had a rocky start, but they've got their feet under them. They're doing well. They actually use the same thermal oxidizer technology and company that we use. So now we've got their data. It is now publicly available on the effectiveness of PFAS destruction and thermal oxidation for the synthesis gas.
And you're also creating biochar, which actually is
they are. They're a gasification facility.
I don't know about them. I'm just saying you. The biochar is fantastic for the soil. I mean, it's not like land applied sewage sludge. This is an actual high value product that would be fantastic for land. Which
we have a minute. I'd love to talk about. If we have a minute here towards the end, I'd love to just talk about the product itself and some of our field trial results.
Go for it.
Anyway, back to what we're doing next. So we engaged with that industrial development agency in that county. We found a suitable location. We've already had multiple meetings with the DEC. We have not filed the permit applications yet. We learned a lot from the past. We're trying to get all the questions answered before the permit applications are submitted. And we're meeting with the planning board for the first meeting this month. and they already know about it. We've already met with the town council and so on and so forth. It's just a much better approach. I've already got, instead of waiting until later to get political support, I've been working on getting political support up front. So now we have from village council through state assembly members,
Smart.
state senators, even the U.S. congressperson that covers the area understand it. They're supporting it. Have all committed to, write letters in support to the state for the permit applications and so on. So all that's all much better aligned, completely aligned this time. And that's also a smaller project. It's basically a single phase. We're not asking to be permitted for more than one process line. So it's 1/3 the capacity of what we had proposed for Monroe. And we've also changed the tail end of the air emissions control system. We removed the dual bioscrubbers and replaced it with a very large dual activated carbon silos. So, and that's made the state regulators so far seem pretty happy about it, because if by chance somehow some PFAS at some level has managed to escape all that destruction capability and efficiency in the system and gets through to the end, it'll get caught in the carbon scrubber. It won't get through a large activated carbon scrubber. And also, if any fugitive mercury or cadmium, there are trace amounts of heavy metals. The permit would allow very tiny amounts of those to be emitted in the air, but we'd rather catch it. The carbon scrubber will get it all. And then we just have to replace the media like twice a year. And one of the cool things is we can actually make the filter media because we're carbon manufacturing.
I was about to say, you're making it.
So I think initially
right?
what we'll propose with the regulators initially is to buy a kind of a certified wood-based activated carbon media for the filters. And we'll have 2 filters. So one is always operating, because then you can always switch to the other one when you change the media. That's the reason for 2. And what we'd like to do sometime down the road with the regulators' support and understanding and permission is to do a stack test on a filter change where we're using the media that we make, because that could be really efficient if we could be using our own. And biosolids biochar is very rich in minerals, so it gives it a very high cation exchange capacity, which means it's a very effective magnet as an activated carbon, for whether you're using for filtering water or filtering air emissions or whatever. So it should work pretty well. We'd like to have the opportunity to prove that. We would switch over to that carbon filter. We would do an immediate stack test. And if we don't get the immediate results that we're looking for, we'll switch it right back, but we're quite confident it'll work very, very well. And then ongoing, we wouldn't need to buy carbon from a third party source. But
it's full circularity, which is really, it's full circularity.
We're trying to get as much of that as possible. So, and within the process, I think I mentioned before, we use the heat generated by the thermal oxidizer when we combust the synthesis gas. All that hot air is used to dry the inbound biosolids. So we have to use a little natural gas to start the process. But once it's up and running, the drier portion goes autothermal, because we're using all the heat from the thermal oxidizers to dry the inbound material. It goes from, the average is like 79% water content down to 5 to 10%.
Yeah. That's Pyrig. Pyrig has something like that in Germany that we filmed. So it works. I mean, it's up and running in Germany already. And it's not like you're doing something that is unknown now to people, which is great. So now you've cited it in places that have all the permits and things, and you have other municipalities reaching out. That's fantastic. So what's the product that you are making?
Yeah. So we did a field trial in the summer of 2024. We got permitted to bring 150 tons of dried biosolids from the Chicago North Shore Water Reclamation District, where they have a very effective biosolids dryer facility that operates at quite large scale, where they take in biosolids from that whole northern Chicago area and they dry it all. And they actually have this thing operating right in the middle of a suburban area with multi-million-dollar homes around it. It's been operating now for, I think, about 10 years, and they've never had really any problems with odor complaints or anything. They're a model. They're a good working model for how to set up a biosolids receiving area where you handle it all indoors in an in-ground pit that's covered with negative air pressure, where all that air is treated and the odors are removed, and the biosol and the odors, basically all the air is pulled right through the dryer, and it's all treated and removed. And so it's an excellent example. Anyway, that's another topic. But we got 150 tons of dried material from them, brought it down to a facility in the central U.S., actually at a farm, and we got a pyrolysis kiln on loan from the Department of Energy, actually a pretty good sized one that when you really get it tuned in and operating, it can process 2 tons per hour of dried material. So it's not small. And we ran a very effective trial. We pre-tested all the feedstock. We did lab analysis of the dried biosolids. We brought in sawdust from a local sawmill. We analyzed the sawdust, and then we made biochar with sawdust added, so about 90% biosolids, 10% wood, and then we made biosolids only char, and we sent all that off to the lab to have the biochar tested. The results that came back were fantastic. We found out one really interesting thing, kind of a learn the hard way. For the first portion of the trial, we were using the groundwater source from the farm for cooling and condensing of the biochar, because you really have to cool it. It can self-combust. If you pile that stuff up when it comes out of a kiln at high temperature, it'll ignite and it'll just turn into a bunch of ash. So we needed a water source for cooling, and we used the groundwater. That also helps agglomerate dust, and it makes it easier to handle, and it gets rid of the dust problem completely. So we were doing that for the first portion of the testing, and we sent off, about a third or so of the way through the processing of all that material. We sent off for initial lab tests, and we had found PFAS varieties in the biosolids. And then when we did the testing of the biochar, all of the PFAS compounds that were found, the several that were found in the biosolids, were not present, but a PFAS compound that was not present in the biosolids was in the biochar. So we're like, what the heck is going on here? Must be the groundwater. So we sent the groundwater off to be tested, and there it was. The PFAS in a much higher concentration was in the groundwater, because this farm had received biosolids for land application as a soil amendment and fertilizer for 3 decades. And they had one persistent long chain PFAS compound that was in the groundwater. We immediately let the property owners know and said, hey, get a carbon filters on this water right away. Don't drink this, And so it was a discovery that they were grateful for. It kind of screwed us up for a minute, though, because we're like, what the heck is going on? But it didn't take long to figure that out. So then we just simply stopped using the groundwater. We continued the test, and we took a large area that was a concrete slab, and we just simply were spreading the material out and very, literally like 2 inches deep, and spreading it out and letting it air cool. And then, after it was nice and cool, after 24 hours, pile it back up. And then we were sending that off. We sent that off to the lab, and it came back PFAS free. So it was an interesting learning experience. But anyway, so from that field trial, we produced about a little over 70 tons of biochar. And we have a bunch of it still out in Iowa, and we sent about 45 tons by truck over to New York to a bagging facility. We had created a brand. We have a brand called Elemental Carbon for our product, and we bagged and palletized about 40 pallets of 30-pound bags, and I've been distributing that out to several farms, doing field trials. We had very successful trials across the board in 2025. We had a flower farm. We had a Christmas tree farm, which I was really worried about, because Christmas trees or conifers like soil that's more acidic and biochar. But it actually, the results in the Christmas tree farm were fantastic. They had bud rates on the new trees that were 3 to 4 times more buds per little tree versus the control set. So they were very happy with the results.
I'm not surprised.
And they want to continue. So we're going to continue the trial in all these places. We're so happy. They were like, we'll take a bunch more free product. This worked out really good for us. And we're going to continue these trials through the summer of 2026. But we also did a flower farm. They took a really nice approach. They had an area that they wanted to use of outdoor soil growing area that was very sandy. It was on a hillside where it had been cleared with trees many decades ago, and just many, many years of too much water going through it. It had turned it into like sand. It had never been really farmed very much, but it was terrible soil. It was like sand. And we over inoculated that. And so we normally would recommend about 1 ton per acre of our biochar as a fertilizer or soil amendment. In that location, I think our ratio was about 3 tons per acre. and the results were unbelievable. They planted flowers in some of the worst soils you can imagine that had a lot of biochar in it, and the flowers planted in those rows did far better than the flowers that were planted in fertile soil that had been treated with compost and organic matter for many years. The results were staggering. I mean, we're seeing plant growth tissue rates that were 30 to 50% greater than the control sets, and root masses that were 3 to 4 times more so than the control sets. And they were very happy with the whole thing. And so they're happy to continue the field trial. And they were great about it because they took a very scientific approach. They have a real horticulturist who runs the whole thing. And she was like, she charted everything out, like perfect note taking. It's like, I thought about how am I going to help these, some of these folks, just do proper scientific approach and data collection. And so what with her, we didn't.
They did that well.
That's all over.
Yeah, I have images of corn, different root balls from corn stalks, one with biochar and one without in Bolivia, and it's a staggering difference.
It's amazing. So, I've got pictures of root masses with plants from control set to biochar inoculated soil where all the soil was shaken out. So it was plant pulled out, all the soil shaken out, gently got rid of all the soil, and then rinsed it. And you can see the root mass is 4 or 5 times greater than control set. And you can also see how the root tendrils grew around and held the biochar. So the stuff that's still in the roots are biochar granules.
Because it's providing all of the nutrients. It's incredible.
What we've found is that just like plants and trees will grow towards the sunlight and the roots will grow towards the water source, the roots will grow towards the nutrient source.
Of course.
And biochar that's loaded with minerals, it's basically an on-demand nutrient source. And one of the things that I've been trying to evangelize on the biochar side, the product side, is that this material is bonded in carbon. It's not water soluble compared to all the other stuff that we use. Even the organic matter that we're adding, it's not carbonized. So you're still going to lose so much of it to, the next couple of rain cycles or to whatever irrigation schedule you have on your farm. Most of it's going down to the river. I mean, most of the nitrogen, phosphorus, and most of the NPK that our country has purchased from abroad or manufactured and used on the breadbasket of the United States throughout the central U.S. Most of it by far has gone down the Mississippi River and has absolutely ruined the Mississippi Delta. There's an aquatic dead zone there the size of New Jersey, and the reason it's there is because of all those nutrients washed away, went down the Mississippi, and have created algae blooms and depleted oxygen and made it inhospitable for aquatic life in a huge area on the Mississippi Delta. So that's where it came from. But biochar doesn't do that. It's not water soluble, and the nutrients are bonded to the char. So the plant roots grow to it, attach to it, and they literally take what they need and it stays there. That's why, I don't know, biochar is a fertilizer industry. Maybe it's kind of a going out of business strategy long-term because, year after year after year, you'll end up needing less and less as opposed to more and more. And all of that synthetic fertilizer is bonded in sodium. It's all in salt, and salt is corrosive in soil. That's why in all of our commercial agriculture fields, we've lost the microbes, we've lost the bugs, we've lost the fungi because we killed it with salt. It's just simple.
Well, that's what's so nice about biochar as a fertilizer. And we have in our film, again, we have people talking about how different feedstocks create different types of biochar fertilizer and the potential for what it can be in its not early stages, but there's so much more to learn. But yeah, it's very exciting. And I'm to round out this conversation, I would just say I'm glad that you've arrived where you've arrived. I think obviously you're going to have a bright future, and your success is everyone's success because what we've been discussing, it takes care of a really important problem, especially in New York, as you described. There's a problem with biosolids anyway, with the closures now of the landfill, and we don't want to incinerate or land apply. So, it's a win-win-win-win all the way across the board. And I think you're just going to be really busy from here on out because people are going to understand it more.
I mean, this is the tip of the iceberg. It's the tip of the iceberg, Leila. There are over 16,000 wastewater utilities in the United States, and only one of them, which I think you mentioned in Redwood, California, has a small pyrolysis system attached to it. Only one.
Yeah.
So it's
that we have that on camera. It's on camera.
Yeah. So people ask me about like, wow, are you worried about the competition? And, what about Pyreg and some of these other companies out there? I'm like, are you kidding me? We're there couldn't be enough competition in the world at this point to be concerned about. This is the tip of the iceberg
Right.
for the market specific to biosolids biochar. But yeah, I appreciate the interest, and I'd love to have Tree Media stay involved and kind of watch the evolution of our first merchant facility that we're developing here in New York, and that'll be public information soon, and yeah, that'll be fun too.
Thanks so much, Raymond, and we'll catch up soon when we have more to talk about.